This is V-belt drive questions, but we have to remind ourselves that how the V-belt drive looks like. This sketch is for V-belt drive, which has two sides of the belt. If this large wheel is the one driving and if it is said to be pulling this way, therefore the tight side will be this top labeled T1, and slack side on bottom side labeled T2. The tight side is where the pulling strength of the belt is more, and force on the slack side is a little bit smaller compared to the tension on the tight side. This is a formula to calculate these two. It is simply a ratio of belt tension. Sometimes you may find that you have to use more equations to find these tension values. Those more equations include effective tension expression, power formula if power transmitted and velocity given, centrifugal tension formula, etc. Let us focus on these questions. We are requested to find the ratio of belt tension, effective tension of belt and the tensile force on each of two shaft bearings. Remember, this effective tension of the belt is just a difference between tight and slack side, which needs us to get values of T1 and T2. On the problem, we are given a power transmitted value is 250 kilowatts. Convert it to watts by multiplying this 250 by a 1000 like so. And convert this velocity to meter per second by dividing by 60 seconds like so, to 25 meters per second. And convert this degree value to radians using this conversion method. On top we put this degree value given, leading to 2.88 radians. Then this V groove angle, which we say cosec equals 1 over sin half of this 40 degrees. Then last given is this coefficient of friction. Now, the first question is to find the ratio of belt tension. Apply this tension ratio formula, where this e to the exponent angle of contact times half V groove angle times coefficient of friction, which leads us to T1 over T2 equals 5.39, that is the ratio of this belt tension that this question 1 is looking for. Now for effective tension, we have to find each tension value, which we now take this T2 to the other side of equal sign and make it equation 1 as so. Then, because we are given speed value and power transmitted value, in that case we apply the power transmitted formula and rearrange it for T1 and T2 to be a subject of the formula because it is what we are looking for. Dividing this power transmitted value by this speed value leads to T1 minus T2 equals 10,000. Then, instead of T1 we put this 5.39 T2, which gets us T2 to be 2277.90 newtons. Take this T2 value to substitute in this T1 equation like so. We get T1 to be 12,277.90 newtons. Now back to the effective tension formula, which gives us 10,000 newtons. For the total tensile force, we just add the tension values T1 and T2 together, then we divide the total number by 2. The number we get from there, it is the tensile force on each shaft bearing, or you may say tensile force per shaft bearing.